this assessment asks us which oxygen, the carbonyl oxygen or the hydroxyl oxygen, would be most likely to protonate if benzoic acid were allowed to react with a strong acid. There are two ways we can answer this question. We'll do it both ways. The first is to consider the two products that we could form. If we want to know where we're going to protonate, let's protonate them both and see if one of them is more stable than the other. And so we can protonate the carbonyl oxygen to give this structure, or we could protonate the hydroxyl oxygen to give this. Now let's start with protonating the hydroxyl. We have a positively charged oxygen, and that's about it. We don't love the positively charged oxygen, but we're going to have a positively charged oxygen here. There's just nothing more that we can really say about that positively charged oxygen. Well, what about this one? Well, it turns out this positively charged oxygen can be stabilized by resonance. As a result, this conjugate acid would be the one that is more stable. And since this is the one that's more stable, we would expect to protonate this oxygen preferentially. Now, I mentioned there were two ways we could have done this. The other way would have been to look at resonance structures from the beginning and recognize that if we were to draw the different resonance structures of benzoic acid, one of the ones we would end up with would be the one where we have a negative charge on the carbonyl oxygen and a positive charge on the hydroxyl oxygen. This resonance structure, the fact that this resonance structure exists in the hybrid, also reminds us that this is the more basic oxygen. So we can either look at what resonance tells us about where the electron density is in the starting molecule, or we can see what does resonance, or what does drawing the stability of the conjugate acid based on resonance tell us about the stability of the conjugate acid. And so in either case, we realize that, once again, this is the oxygen that is most likely to protonate.